This video is for Lesson 9-2, Translations. Learning goals are to perform translations on the coordinate plane and translations that don't have a coordinate plane, and to be able to predict the effect of a translation that's described. Maria marches with that marching band. At the start of the halftime show, her position is 2, 4 on the coordinate plane. Then Mr. Scott tells everyone to move 2 yards to the right on the field and 4 yards up the field. The band's transformation is shown in the diagram, and Maria's position is marked with the X. So here's the X at 2, 4, and if the marching band members move 2 yards to the right or 2 units to the right and then 4 units up, Maria's new position would be right there. And so this arrow is pointing from where Maria's previous position was to the new position after the transformation. This type of transformation is called a translation. On the coordinate plane, a translation is described by a function of the form x, y goes to x plus a, y plus b, in which a or b are positive or negative numbers. In the example above about moving 2 yards to the right, a is 2. It's like you're adding 2 to the x coordinate. That would move a point 2 units to the right. And b equals 4. If you add a 4 to the y coordinate, that would move a point 4 units up the coordinate plane. You can think of a translation as a figure sliding up or down, left or right, or diagonally. During the translation, every point of the figure moves the same distance and in the same direction. This distance and direction is called the directed line segment. In the diagram, the directed line segment of the translation is shown by those arrows. So we had already looked at that arrow connecting where Maria's previous position was to where her new position will be when she makes the translation. Complete the table to show how the translation affects 4 of the marching Cougars. So we have Maria located at 2, 4. We've already looked at her in the picture. Joe is at 3, 7. Alfredo is at 1, 8. And Lejaya, we don't know where she was originally. Her new image is at 7, 11. Remember, the function was described by adding 2 to the x coordinate and adding 4 to the y coordinate. The marching band members were supposed to go 2 to the right and up 4. And so 2 plus 2 would be 4, and 4 plus 4 would be 8. Maria's new position is 4, 8. If we look at the grid, here is Maria's new position, and yes, that is 4, 8. Okay, those other members. If Joe started at 3, 7 and moved 2 to the right and 4 up, his new spot would be 5, 11. If Alfredo began at 1, 8 and went 2 to the right and 4 up, his new position is at 3, 12. Okay, let's do one in reverse. If Lejaya's new position was 7, 11, where was she before? So 7 take away 2 is 5, and 11 take away 4 is 7. Mr. Scott arranges the band in a rectangle. Then he directs the band member at 6, 10 to move to 4, 13. The numbers on the coordinate plane show yards on the football field. So remove that rectangle filled with marching band members. And this person right here is at 6, 10. Mr. Scott told this person to move to 4, 13, which I've drawn over on the other grid. So here was the 6, 10, and then if you move left and up, that would take you to 4, 13. Right here in purple is the directed line segment describing that translation. Question 2. For the band to move in a translation, how should each band member move? They would need to go left 2 yards and up 3 yards. Again, that is described by this purple arrow. Number 3, Maria was positioned at 2, 4. Up here in the picture, remember she was this X, that was Maria at 2, 4. Her friend tells her that Maria's new position is described by the function x plus 3, y minus 2, since her new position is at 7, 0. Is her friend correct? Well, remember what they were supposed to do is go left 2 and up 3. Right there's Maria's new position. So is her friend correct? No. Maria's new position is 0, 7, not 7, 0. And the friend's formula confuses the change in the x and the change in the y. That formula should be to subtract 2 from the x, because that's how you go left 2. And it should be to add 3 to the y, because that's how you go up 3. Here are some check your understanding questions, so I'll pause the video. Translations can also be defined without a coordinate plane. For the directed line segment, segment AB, a translation maps point P to point P prime. So the way that you speak this is you say P prime. That little apostrophe looking symbol is the word prime in geometry class. So that the following statements are true. Segment P prime will be parallel to segment AB. So whatever that directed line segment is, so in some kind of picture, if you have a directed line segment AB, maybe it's going in this direction, then point P will move parallel to that directed line segment. And P prime will be equal to AB. So the distance from P to P prime will be the same as the distance from A to B. However long this is how long it will be between P and P prime when you move. And the third thing that's true, segment P prime is in the same direction as segment AB. This is all described in symbols like this. The expression capital T, and then down here as a little subscript, we have our directed line segment, segment AB in this case. And then in parentheses, we have the thing that's being translated, in this case, point P. So these symbols describe the translation of a given point P by the directed line segment AB. So in the above example, the translation of point P along directed line segment AB will create or will map P prime. So I know these symbols are a little strange. It's going to take some time to get used to what these all mean in geometry class. Let's give this a try. Items 6 through 8 refer to rhombus ABCD that is shown below. Point P is the center of the rhombus, so you see that right there. Number 6, draw the translation of the rhombus, so we're asked to draw a rhombus, described by directed line segment AB prime. And include P prime when we draw this. Okay, and again, here's the symbols. What this is saying is the capital T is we're doing a translation. This right here is the thing that we're translating. And then this right here, the subscript, is the segment that we're using as our directed line segment to show us what direction to slide and how far to slide. And we want to translate the entire rhombus. So we want to use segment AB as our directed segment. So this segment right here, from A to B, going in that direction, gives us the direction that we want to slide the rhombus. And the length of this is how far we want to slide it. So think about what's going to happen. If you start with point A and you move it along this segment, for the entire length of the segment, it will stop right there. And then point B will move in that same direction for that same length. So if we had a ruler, we want to measure how long that is. So we get this exact. And then there's where B prime would end up. Point A slides right there, and then A prime is right perfectly on top of B. The same thing up here. These are going to move or translate in that same direction as what this is pointing. So D is going to move right to there, and that point where there was a C is also D prime. Point C is going to slide up and kind of end up here. That would be where C prime is located. And then certainly we can come back once we've located the corners and we can draw in the image of the rhombus. So A, B, C, D was our pre-image, and then A prime, B prime, C prime, D prime is our image. Remember, we were also supposed to move point P, that same amount, and call it P prime. So here in brown is the new rhombus. It should be exactly the same size and shape as the original, and it should be moved in the direction that segment AB indicates for us. Question 7, which part of the rhombus maps onto segment BC? So I've kind of written on top of BC in brown ink now, but BC was here, and so what mapped onto it was segment AD. Number 8, identify a translation of the rhombus that would map exactly one point of the rhombus onto another point. And there are some possibilities. One possibility is to translate the rhombus along segment AC. Think about what would happen. Segment AC is a segment that's going vertically from A to C. If we were to take the entire rhombus and slide it up, then the rhombus would exist kind of up in this area. And point A would have slid and landed on where point C was. Another possible translation is to translate the rhombus along segment DB. Think about what that would do. Here's segment DB. That would be translating the rhombus sideways, moving the rhombus to the right. That would create a rhombus that's kind of, over in this area of the paper, right? Can you visualize that without me switching colors or anything? And point D will have moved and landed on where point B was. Okay, number 9. Draw the following translation, show the pre-image and image, and label corresponding points in each. Question A, square ABCD. I've already drawn the pre-image in purple just to save time. Let's translate this 4 inches to the right. So as soon as we see 4 inches, we know that this would require a ruler. Now I can't easily do a ruler on the video. Let's make believe that this original square was 1 inch long. So if we want to translate it to the right, we got to take every dot on the square and move 4 inches to the right. So let's say that was 1 inch, 2 inch, 3 inch, 4 inch, and there's where the new top left corner is. We'll call it A prime. And then because a translation is a rigid motion, we can create the rest of the square. We're going to keep it exactly the same size and shape as the original. This is B prime, C prime, and D prime. Again, imagine using a ruler so that going from there across to there, we know for sure that that is 4 inches. Okay, question B. Take right triangle ABC and translate it 3 inches up. So I've already drawn the triangle just to save some time. We want to move it up 3 inches. Again, let's make believe that this purple side is 1 inch long. So we would go up 1 inch to there, 1 more inch, 1 more inch. And then draw the triangle, exactly the same size and shape as the original. Here's A prime, sorry that it overlaps my square, I didn't plan that very well, B prime and C prime. So the brown triangle is the translation of the purple triangle. Question C, let's take right triangle ABC, here it is down here, and translate it by this translation. Let's talk about what this means again. Capital T means translate, and then the subscript is the segment we're translating along, AB. So from A to B, this provides us the direction that we're sliding as well as the distance that we're sliding. So point A will move until you get to point B, and that's where A prime will be. Point B will move in that same direction and the same distance to create B prime. Again, so we'll point C to create C prime. If you are careful and accurate and you use a ruler, I should have used a ruler right there, right? You will get a triangle that is exactly the same size and shape as the original purple triangle. This is called A prime, B prime, C prime. Here are some check your understanding questions, so I will pause the video. All right, the learning goals were to perform translations on the coordinate plane. These involve adjusting the x and y values, adding or subtracting numbers to the x and y values to move points. We also did translations off of the coordinate plane. To be accurate with these, I strongly suggest using a ruler. We also predicted the effect of a translation on a figure. So for instance, if we had a translation described, as an example, move 2 to the right and 3 down, that we would be able to predict the effect on a shape of doing that slide.